Alternative fuels. And what I'm going to do now is just go through a few examples of different technologies that's in our portfolio that we mix and match across our various vehicle segments. So alternative fuels, we've been a leader in providing flexible fuels for many years. We have over 4 million flex fuel vehicles in operation, 11 models in the U.S., including very high volume models, F-150, Fusion, and Escape. They all come in flex fuel variants. We are in the process of launching our diesel Power Stroke engine with the capability of supporting B20 biodiesel. And we've worked with our commercial customers to make sure that our engines can be CNG capable and support them in their CNG conversion on vehicles like our Transit Connect as well as our Econoline. So the way you can think about delivering fuel economy is it's just a big puzzle. You've got all these tools, all these technologies in your tool chest. You've got some bigger items to look at like overall vehicle size, weight, et cetera. And you have to put those pieces of that puzzle together just right to deliver the right fuel to the customer at the right value so that your sustainability message can come through. And what I'd like to do is just talk about in each of these little puzzle pieces what are some of the technologies that we utilize today that are encompassed in there. So the first is our Aero strategy. I mentioned in the pillars that Smart Pillar, which is also design, encompasses delivering world-class leading designs to our customers. Well, part of that also includes delivering very aggressive levels of aerodynamics. And one of the key enablers that we've had over the last few years is going from a process where the studio designs the design that they want, and then the aero engineers come in and they put it in a wind tunnel, and then they collect the data and they understand where they are with respect to aerodynamics, and then you go back in the studio and you try to, modify the design, if you will, so that you can meet an aero target or make some other types of decisions. What we've gone to now is a capability where we analyze simultaneously, analytically, with our designers so that we know up front the design they're heading down, what they need to do and what we need to do together to deliver also on those aero targets. We also use a lot of just traditional technologies, an underbody shield to just smooth out the airflow under the vehicle and help improve fuel economy. I mentioned our weight reduction strategy. There are a myriad of technologies out there that can support weight reductions, from the obvious, switching materials, going from steel to lighter weight aluminums or magnesium, to the fine attention to detail. How big can I actually make that radius as I'm taking material out? Are there lightning holes I can put in this particular component where structurally it's fine to go ahead and take some of that material out? How thin can I go in terms of down gauging? Oh, I think I went too far. There we go. How thin can I go in terms of down gauging the materials that I'm using, the sheet metal that I'm using? Those are all tools in the Weight Engineers Toolkit, in the Design Engineers Toolkit, as we go forward to develop our products. And then there's that puzzle piece called fuel economy technology. There is no shortage of fuel economy technologies out there. In fact, I'd say once a week I get an email from somebody telling me about a great technology that they've got available, as well as those emails that tell me about the engine that works only on water. So you do have to kind of sort through some of that. Did you write that one? No. So this is just a small list of the technologies that are out there and available. And these are the ones that I would say are on the forefront of what we are cascading and managing within our products. And I think I'm just going to pick out and talk about 3 of them. The first one is auto stop start. This is personally one of my favorites because the rest of those technologies that were listed there, if we've done our job at Ford Motor Company, a customer does not know those technologies are there. They just know they're getting great fuel if we've done our job. Auto stop start is one where they actually, even when we've done our job perfectly, they will know that they have this. This is the, hey, let me call my neighbor, they've got to come over and check this out kind of technology. You can show it, demonstrate it. Obviously, stop start is when you're rolling, coasting down to a stop, or your foot's on the brake, you're at idle, the engine shuts off, thus saving the fuel that you would normally expend to just keep the engine idling. Overall, that provides about a 2.5% fuel economy benefit. Depends, of course, on the actual driving cycle. But it also does something more. It gives the customer a bit of a feeling that I'm doing something here. My vehicle is being more fuel efficient, just like hybrids do. When a hybrid runs on the electric mode, that customer knows I'm saving fuel right now. So I really do like this technology. It's rolled out in Europe. It's a little easier to execute on a manual transmission than on an automatic. So the technology started first on our products in Europe, but we will see it migrating here on automatic transmissions very soon. And again, I think it's one of my personal favorites. Another technology, and now we're at the other end of the spectrum, improving fuel economy at highway speeds, is something we call active grille shutters. It's simply a set of shutters in front of the radiator that you can electronically open and close depending on the conditions under the hood of the vehicle. Now, when you close them at highway speeds over 30 miles per hour, so you're more in the highway driving range, you can change the coefficient of drag across that front of that vehicle, and you can change it for the better to get better fuel economy. There's also a little bit of benefit with active grille shutters in terms of how you can warm up your engine. So if you shut the grille, you don't allow that heat to escape through the front grille, and then your engine oil and your transmission fluid can heat up a little faster. If they heat up faster, they'll be less viscous faster, which means you'll get a little bit better fuel economy. But overall, this is a highway fuel economy benefit on the order of 0.5 to maybe 1%. And the last one I'll talk about is aggressive decel shutoff. This also is aptly named. As you're coasting down, or as your foot, I shouldn't say coasting down, your foot's off the gas, we use some torque management techniques across the transmission to be able to shut your fuel off. And then as soon as you demand more torque, we turn that fuel injector right back on as your foot is accelerating on the throttle pedal. And again, that provides some great fuel economy for our customers, between 0.7 to 0.1%. But again, this one, they shouldn't know it's there. If they can feel us do that, then we still got to go back and do some more work because it wouldn't be right. So how is this all paying off for us as a company? We believe that it's paying off very well for us. Ford Motor Company today features 12 vehicles with best-in-class fuel economy, and we have 4 vehicles with 40 miles per gallon or more today in our showroom. We have the Fusion and the MKZ hybrids at 41 miles per gallon. We have the Fiesta, which we launched about a year ago, that has 40 miles per gallon, as well as the Focus, which we've just recently launched, which also has a 40 mile per gallon variant. Now, no discussion on sustainability would be complete without a dialogue around electrification. And the circles here indicate where we've described electrification in both the near, mid, and long term. We have hybrids today. We will continue to grow that technology in the near future, and they will continue to expand in the long term. So in terms of our electric vehicles right now, we do offer a full family of electric vehicles. Hybrids, we have a plug-in Escape that we work with some of our commercial customers with, as well as a Transit Electric that we do with our partner Azure. And then, of course, we have Fusion and Escape full hybrids available for our customers. Now, going into the future, this is just a little snapshot of how we're migrating to more and more electrified product. In the near future, by 2012 in North America, 2013 in Europe, we will introduce 5 new electrified vehicles in those regions. Battery electric vehicle we have today at Transit Connect, and very soon we'll be bringing out our Focus Electric. So our Focus that we just launched will have a full electric variant available soon. We'll also have, off of that same C-Car global platform, we will have a plug-in hybrid as well as our next generation full hybrid. And then we'll continue as we evolve our Fusion and our MKZ to offer full hybrids in those products also. So, in summary, where are we in terms of sustainability and delivering on that promise that we set out on and that a goal we set out on over 5 years ago? Basically, we think we're well on track, and more importantly, we think our customers would agree with us on that. Our plan is based on product and operational excellence, and it requires people working together as a lean global enterprise. We also decided to use technology as a differentiator, and we think we've done that also. We think we've introduced technologies to our customers that sets us apart from some of the other automakers. Our features and technology content have improved the comfort, convenience, the safety, and most importantly, the fuel efficiency that our customers get in our products. One of the key foundations was making a commitment to deliver sustainable technology that could be afforded by millions of customers. And again, with our EcoBoost strategy, just based on the value equation, we've done that. And the path to electrification, while we certainly believe that's where everything's going, exactly when you'll get there and at what rate is dependent on things that are actually outside us as an auto manufacturer, as an auto OEM. Really depends on governments and utilities support for infrastructure, and it depends on the guys that are deep down into the chemistry of those battery cells, that battery cell material, really making some breakthroughs with respect to what we can deliver in terms of a range to our customers. With that, I believe I have covered everything I intended to cover. That was a whirlwind tour of our sustainability strategy, but I do believe we have time for questions, and I'd be happy to take any, if any came to mind. So everyone can hear, the question was, what percentage of our vehicles do we think are going to be electrified, 10 years from now? So let's say 2020, 2025 time frame. We expect about 25%, and that's Ford's prediction, and we're pretty well lined up with a lot of third-party predictions that are out there too, would be some form of electrification. The vast majority of those, they will be hybrids. They'll be either plug-in or the full hybrid. Again, battery electrics are going to require a little more infrastructure, or a lot more infrastructure, depends how you look at it, as well as a cost-value equation that makes sense to the consumer to really start to proliferate. And the other thing I always point out with that answer is that's product in what I'd call developed countries, Japan, United States, Europe. In some of the emerging markets, I don't think that is going to be as high. I think it's hard in some of the emerging markets to visualize how electrification will displace traditional combustion engines at the same kind of a rate.
I just want to congratulate you on making the Ford products appetizing. We've got wheat straw, sugars made from corn. I can just eat this focus.
Yeah, you know what, the coconut, I saw some of the samples that they put together of, they were coconut-based material that we could use in our designs. Maybe it's in the instrument panel, maybe it's in the center stack or in the console, and they're really beautiful textures. So now we got to get our studio guys, the pros, over the hump on this.
Yeah, that leads me to my question, my serious question. Thank you for a nice presentation, first of all. But two questions, actually, three. When you go to extreme,
is that allowed? I have to check first. Three questions.
He's president emeritus.
Okay.
When you go to extreme lightweighting, and Ford has long been a leader in safety, the laws of physics are pretty absolute. How do you maintain levels of safety when you take so much mass out of the vehicle? First question.
Let me answer that, because then if you ask me the other two, I'll forget the first one.
Sure.
So if we take them in order, it'd be easier. The laws of physics are there, but there's absolutely nothing that we've seen and that we've demonstrated that indicates in any way, shape, or form we have to back off on safe product to go lightweighting. It's all about energy management, and where the real solutions for customers lie in delivering incredibly safe products is how you manage that crash pulse as it goes through that vehicle. And we can do that equally successfully whether that vehicle was made of steel or whether that vehicle is made of aluminum. So we have the tools to analyze it. We have the design engineering community to take those results and build the types of safety features that we need into the fundamental structure, and we really can do it either way.
Now, magnesium burns quite spectacularly when it ignites. Did you factor that in when you added magnesium to the NK series?
Well, we've got, magnesium has been around as an automotive part for a very, very long time, and I'm definitely not a chemist, so I don't know all the gory details of it. I think the concern you're referencing is one more in the manufacturing stage when people are manufacturing with magnesium, but I am unaware of any situation where a magnesium component, and it's used in intake manifolds, it's used as cam covers, across the industry, has ever had any kind of an issue. It's a robust metal. The bigger problem is one day aluminum's cheaper by the pound, the next day magnesium's cheaper by the pound. So one day you're off running, designing one in aluminum, and the next day you're off running saying, oh, I should change it to magnesium.